Good afternoon. My name is Ajpal Singh. So today I'll be presenting about the material, type, and also configuration of the membrane. Let's start off with the introduction. Introduction is where basically we are given methane which contain contaminants such as water, hydrogen sulfide, and also carbon dioxide. In order for us to remove the acidic gases such as hydrogen sulfide and also carbon dioxide, a membrane will use. Meanwhile, to remove the water, absorber will use. So let's start off with the membrane material. So membrane material, the type of material we use is the fluorine-containing polyamide. This is because it has the highest selectivity for carbon dioxide. It is also stated that the concentration of carbon dioxide is higher compared to hydrogen sulfide. Thus, using one membrane material, we can separate the acidic gases from the CH4, which is methane. So the type of membrane used is hollow fiber. This is because it has a higher efficiency compared to other membranes. It is also said to have a smaller diameter, so thus it has a larger surface area. Hollow fiber consists of microscopic pores or holes, so it is easier to remove the reactant tape. So let's move on to the final part, which is the configuration. So membrane configuration is where basically this type of membrane works the same as spiral wound. It's where it utilizes the tube diameter to enhance flexibility. It is also said to withstand high amount of pressure. So it contains large number of individual membrane with a very so it is more efficient. So that's all from me today. Let's move on to the next part. Thank you.
Hello, sir. I'm Sim Junjie. I'm going to present our design of the separation process and the result we obtained from the membrane separation unit. First of all, the inner temperature and pressure were set, which are 70 degrees Celsius and 70 bar. Based on the diagram above, two membrane separators, one compressor, one absorber, and one mixer are needed and designed for the separation process of carbon dioxide and hydrogen sulfide. The feed will be entered to the first membrane separator unit, and all the water vapor is assumed not removed by the membrane and transport into the absorber for water vapor absorption. Then we will get our first product at stream 4, and excess water vapor will be removed from stream 9. Besides, the compressor is used to increase the pressure of the permeates for the second membrane separation. After the second membrane separation, most of the carbon dioxide and hydrogen sulfide will be removed out from stream 6, and we will get the second product at stream 7. Lastly, the mixer is used to combine the first product and the second product. The final product is formed, which is in stream 8. The final product is the required purified natural gas, and it should achieve the required specification. The whole process is assumed to be an adiabatic process. Besides, based on the calculation, in the first membrane separator, the composition of the retain is shown in the diagram here, and the water vapor will be absorbed by the absorber in the next process. At the same time, most of the methane is separated by the membrane, so we need the second membrane separator to recover the methane. Based on the result of the second membrane separator, the methane is recovered and most carbon dioxide and hydrogen sulfide are removed. Based on the calculation, the final result is obtained and all the composition are achieved the specification. So that's all for my presentation. I would like to pass to my teammate to continue the presentation. Thank you.
Good day, I am Lee Inwood and I will be presenting the reaction engineering part, including the designs and calculations. First and foremost, I would like to introduce the main product of our reaction, which is chloromethane. The usage of chloromethane is wide and it is used in formation of products such as silicon, ethyl cellulose, and refrigerant. In this case, the team is required to design a reactor to increase the selectivity. For the type of reactor used, the team decided to use a mixer and a PBR with a solid catalyst named as sulfated tin oxide. The operating condition here is 350 degrees Celsius at 1 atm. These are the assumptions made for the reactor, which is isothermal, steady state, negligible contaminants in methane flow, and so on. Let's move on to the type of catalyst used. The team has compared 4 different catalysts in different perspectives and to determine which is the best catalyst.
By assuming the optimal condition at 350 degrees Celsius and pressure of 1 atm, STO is the most suitable catalyst that is used in this case.
Not only the price is average and acceptable, it has the highest selectivity towards the formation of chloromethane that is around 96 to 98% and does not require an additional reactor. In addition, we are going to talk about the strategies to maximize the selectivity and yield of a product by reducing the side reactions. Here are some examples. Choosing a correct catalyst, use a continuous flow reactor instead of a batch reactor, Determine the optimal feed ratio and replace and regenerate your catalyst frequently. Along here, the team is instructed to determine the size of the reactor. However, because this is a complex reaction, a catalyst is used and it is assumed that other reaction is small and assumed to be negligible. To determine the sizing of reactor, here are a few steps.
First, determine the mole balance and rate of reactions that is obtained from reviewing literature. Besides, a stoichiometry table is done accordingly by assuming isothermal gas-phase reaction.
Since a PBR is being used, a few equations such as the Ergun equation is used to determine the volume of the reactor. The value that you can see from the slides are being obtained through textbooks and articles with reliable evidence. After that, the team combines all of the equations that have been stated before and solve accordingly to find the weight of catalyst with initialized boundary. With the weight of catalyst being known, other parameters can be determined such as the length, the volume, and the pressure drop. The team plays around with the value of the diameter until a desired result is obtained and the answer is acceptable. In short, the final results obtained is when the diameter of the reactor a weight of catalyst of 45 kg and volume of 0.01190 cubic meter. Lastly, the cost of the system is being evaluated and it is estimated to have a net profit for around 70 million ringgit Malaysia per year. In other words, it can be determined that it is appropriate and enhancing to invest on this project. That's all for my presentation. Thank you.
My name is Mohammad Nur Hamdan and I will be presenting about the process modeling and simulation for our integrated project. So for this simulation, our process is the chlorination of methane and we use packet bed reactor as the main reactor. With the selection of catalyst, we use sulfated tin oxide. As a result, the mole fraction for our desired product, which is the chloromethane, is around 0.0535. Same with the HCl, which is also 0.0535. However, there was slight difference in the volume of reactor between our manual calculation and the value in the simulation itself. After we calculated, we found out that the deviation error between the manual calculation and the value in the simulation is around 5.68% of deviation error. Thank you.
So as a conclusion, this integrated project, which include for 3 courses, have been done successfully. All the designation part have been done by considering all the aspect related to it. And lastly, all the calculation part have been calculated and solved by stating some of the assumption and referring some the reference from the website. So that's all from my group. Thank you.